This tutorial is about numerical differentiation, second order difference. So it's the numerical implementation of the second order derivative, and it's it's second order because it requires 3 points to compute, and so we can implement this 3-point implementation using the MATLAB code. It's very similar to the first order implementation, but first we find out the symbolic version of it. Again, compute, find the symbolic, create the symbolic function, but then when you find the derivative using the diff function, to put the second order derivative, put 2 after that, and that means I'm differentiating y but to second order, and then I'm calling it d2y by dx2, and d2y by dx2 is minus 2 sine x minus 1 over 5, which is a shifted and scaled sine wave. And again, we plot these to see what they look like, show graphics. And so this is the function and this is the derivative, second order derivative of that function. Now in order to do numerical implementation, we again create some samples. So x's are our samples and y's are the corresponding function values at those samples, and again we compute the second order derivative using this numerical implementation. Just make sure that you divide it by delta x squared, and then we plot it. So again, note that in this case the for loop is going from 2 to n minus 1, because at each point we need one previous value and one forward value. And so because for these last points there is no forward value and previous value for the beginning, that means we won't be able to find the second order derivative at that point. And this little part is basically just removing the 0 that appears because we start from 2. MATLAB automatically gives x underscore 2d1 a value of 0. So if I run this code up to this point, you will see that it has created x2d with a 0 in the beginning because we started from x2. So this little piece removes that 0 from the array, and then we can plot it. So now if we plot this, we can see that how the second order derivative is approximated by these difference equations at these sample points, and we can improve this estimate by again reducing the sample size or reducing the interval size, and we can keep improving this estimate by as we continue to reduce the sample size. So you can see how this gives us quite reasonable estimate of the derivative.